गुड मॉर्निंग फ्रेंड्स। आज हम लोग डिस्क्रीट मैथमेटिक्स का टॉपिक स्टार्ट कर रहे हैं, सेट। व्हाट इज बेसिकली सेट इज? अ सेट इज एन अनऑर्डर्ड कलेक्शन ऑफ डिस्टिंक्ट ऑब्जेक्ट. Important point, it is an unordered collection of distinct objects. The objects should not be repeated. If it is repeated, they are not considered as a distinct object. For element belongs to a set, it can be written as A belongs to a set element A. Here, if element does not belong to a set, it can be written as B does not belong to a set A. As we have already said that two element belonging to a set must have a similar property, but not always. It cannot be always an object in a set have similar property. It can be possible sometimes the set element do not have a common property in between them. So that's why it is written as unordered collection of distinct object, because they are distinct, so it's not required to have a similar properties. Roster method, we have two method of writing the set. Is first is roster method, second is cell builder notation. In roster method, we uses a curly braces. We can write as A, B, C, D element of a set in the curly braces. In the set builder notation, we must have to specify the stating the property for which the elements are being collected. So it can be written as X such that X has a property P. For example, we have taken here X belongs to Z plus, that is integer, positive integer, and X is odd and X is less than 10. So this is a set builder notation, and here we write as roster method where the elements of the set O is 1, 3, 5, 7, 9, which hold this condition. Now we will continue with the types of a set. First of all, we have a equal set. In equal set, we have same element in a set. There, if here it is written A, elements are 1, 3, 5, and set B, where it is written as 3, 5, 1. They are equal set because they are having a same element. Set C, 1, 3, 3, 3, 5, 5. As we have already said in previous, that set must have a distinct element, so they are not counted multiple times, they are being considered as ones. So here also we have three elements, that is 1, 3, and 5. So we can say that the A, B, and C set are equal set. Now we have the next is empty set, which is called as null set, in which we do not have element. So it can be written as phi, or it can be written as curly braces, and no element will be present here. Next set is singleton set, where we have only one element, is called phi, or it can be written as, this one also is being considered as a singleton set. Next we have a subset. If every element of A is also element of B, it is called as subset. Here A is a subset of B. For example, you can take as A we have an element 1 and 2, and in B we have an element 1, 2, and 3, and 4. So we can say that if every element of A is also element of B, here you can see that every element of A are 1 and 2. It is also being presented in B also, and B other than that also it considered an element. So A is a subset of B, and B is a superset of A. Next topic is size of the set. Exactly n distinct element is called as a size of the set, or you can written as a cardinality. For example, we have to calculate the size of the set A. Is we having a 2 elements, so cardinality of the set A is 2. If we calculate the cardinality of the set B, we have 4 distinct elements, so cardinality of the set B is 4. Next topic is a power set. The set of all subset of the set S is called as power set. Here example, we have given a set A having elements 0, 1, and 2. So we have to write the power set of A. We have to write every element over here. We have write the phi element, which is a subset of every set. So we have written phi. Then we have written all the sets 0 and 2. Then we have write the combinations of this 0, 1, 0, 2, 1, 2, and 0, 1, 2. So we have here 8 set in the power set. So n distinct elements, power set has 2 की power n elements. So now again we have to consider one example. It's the most important concept. It is being used mostly in the exam. What is a power set of 5 set or a null set? The power set of 5 set is, we having a one element that is 5, so we will have 2 की power 1. We have the 2 की power 1, we have might have 2 element in our set. It is 5, and then we have a 5 set also. Next topic is a Cartesian product, that is a cross multiplication of two set A and B. That is, we have an ordered pair of A comma B. Now we can consider an example, that is A comma B is that A belongs to a set A and B belongs to a set B. Cartesian product of A cross B can be written as ordered pair A comma B, where A belongs to A and both the conditions should be satisfied. B also belongs to set B. So here example is, we have A is equals to 1 and 2 and B is equals to A, B, C set. We have to perform the Cartesian product of this. 1A, 1B, 2B, 2A, 2C. Similarly, we have all the possible combinations. Here in this set we have 2 elements, here we have 3 elements. So the product of A cross B elements are being 2 cross 3, that is 6. So final elements of the Cartesian product, if the set A has element B m and B has a set element n, the number of elements in the A cross B is m into n. This is an important point to be remembered. If a set A has a cardinality m and set B has a cardinality n, then A cross B has an elements are m dot n, that is a product of both the elements. Next, the topic is set operation. We have A union B. Here we have to consider the elements from both the set or from both the set. That is, X belongs to set A or X belongs to set B. We have to consider all the elements. In A intersection B, we have to consider common element or AND operation we have to perform. X belongs to A and X belongs to B. In A minus B, that is a set difference form, we have to write the elements should belongs to A but should not belongs to set B. In A complement, we have to take a universe, the elements which are presented in universe but are not the part of a set A. So it can be written X belongs to universe and but X does not belong to a set A. The last topic is multiset. After this, the complete set operation is being set topic is being completed from the discrete mathematics. Multiset is an unordered collection of elements where an element can occur as a member more than once. So here you can see that A 3 times, B 2 times. So by performing the union, intersection and difference of the multiset, we have to consider something different. We have to, for union, we have to consider the maximum times the element multiplicity exists in a 2 set, and in intersection we have to consider the minimum multiplicity of the set considered in a 2 set, and difference is how much less the first element than to this. Here example is, a P is a set where A comes 4 times, B comes 1 time, C comes 3 times, and Q is another set in which 3 comes A times, A comes 3 times and B comes 4 times and D comes 2 times. If you have to perform the union operation, we have to take a maximum. So maximum time of A comes are 4. So we have written 4A. Maximum time in here P and Q, B comes 4 times. Here 3 C comes only this 3C. Maximum time and here there is no C, we have to consider 0. So maximum time is 3C and 2D. And in intersection we consider as a minimum number of times the element comes. So here we have considered 3 comes A times and B comes over 1 times, and in 3C and 2D we consider as the minimum is 0C and 0D. So we will write only here 3A and 1B. Next, last operation is a set difference is P minus Q. We have to take the less number of the element. So here in P set P we have 4 times of A, and Q we have 3 times of A. So less number is, how much less is 1A. So we have considered as 1A. Next, we have 1 times B and 4 times B. So how much less is that? We have to consider as is 0B.